Hello, I am going to help you identify whether an equation or a table is linear, exponential, or neither. First off, we'll start with this graph. Here we have the x-axis and the y-axis. The x-axis is going up by ones, while the y-axis is not doing that. If we subtract the 3 and the 1, we will get plus 2. If we do this to the 3 and the 5, we also get plus 2. We do this to the 7, we also get a plus 2. This is showing that this table is linear. It's going up by a specific number every interval. Then we have the other table. Now this table also has the x-axis going up by ones, but the y-axis has different numbers. If we subtract these two, we get plus 2. But if we subtract these two, we get plus 4. And if we subtract these two, we get plus 8. What's up with that? Well, that's because this table is not linear. It is exponential. If you divide any two numbers on this table, you will get 2. Each term is being multiplied by 2. And here we have another table. And now this table is even more odd. As usual, the x-axis is going up by ones. 1, 2, 3. But the y-axis, there's nothing. That's plus 6 minus 7 minus 1. No correlation. Even if you did division, there's no correlation. It's just numbers. Random numbers that were chosen, which makes this table nonlinear. And you see this equation? If the common ratio and variable are being multiplied together directly, that means the equation is linear. Now this equation looks a little more complicated. If you see that the common ratio, which is this one, is being multiplied to the power of the variable, you know that this equation is exponential. And now this equation is very weird, and you should probably not even touch it unless you're going to do graphing, because the table, without a graph, you're not going to be able to predict the table easily. But this equation is very weird. So how do you know whether it's exponential and linear? Well, since the x is being multiplied to the power of the whatever number this would be in the equation, it cannot be linear, but it cannot be exponential. In fact, on a graph, it makes a shape called a parabola, which looks like this. You see? And that's neither exponential nor linear, which makes it neither.